Assalamu alaikum. I am Jahangir Alam, lecturer in physics. I welcome you all in my online class. First of all, thanks to Almighty that I am still okay and carrying on my regular activities. He has given me the ability to take this class. Dear student, I also hope all of you are well by the mercy of Almighty and carrying on your regular studies, staying at home. Right. Dear student, in our today's class, we are going to discuss some multiple choice question, that is MCQ, from the second chapter of physics second paper, right, that is the chapter of electrostatics. And I hope this class will help you a lot for your exam. So dear student, let's start our class. Dear student, before starting our today's class, first I would like to remind you that though we are going to discuss the multiple choice question, but you need to memorize the mathematical expression or formula, because you know our maximum MCQ question will be based on the mathematical problem. Okay, so to do better in MCQ portion, first you need to memorize the mathematical expression or formula from a textbook. Right, it will help you for your MCQ portion as well as in the creative portion. Okay, I hope you got it. Dear student, our today's first MCQ question is the distance between two charges. Here the charges are -4 coulomb and 5 coulomb is infinity. That is, the distance between two charges is infinity. So what is the force between them? Here them means force between the charges. You know, F is equal to 1 by 4 pi epsilon naught q1 q2 divided by d square. Here d is the distance. If the distance is infinity, then it will be 1 by 4 pi epsilon naught q1 q2 divided by infinity square, and in that case you know the result will be 0, right? So the force between the two charges will be 0 Newton according to our expression. In our second question, they said that if the distance between the two charges is made 1 by 3 times, then the force between them will be, you know, from the previous expression, force depends on the quantity or amount of charges and distance between the two charges. So from the expression we can write that F is proportional to 1 by d square. So using this expression or analyzing this expression, we can say that if the distance is made 1 by 3 times, so force will be 9 times, right? So this is the correct answer for this question. In our next question, they said that what is the unit of electric permittivity of the medium, right? Dear student, you know the electric permittivity of the medium is coulomb square per Newton into meter square. This is the unit of electric permittivity of a medium. In our question 4, they said that where does the maximum charge remain in a charged body? Understand? You know, charge remain on the surface of a charged body, but in the option they said that at the center. So center is not possible, concave surface, plane surface, and finally they said that convex surface. So among the 4 options, the right answer will be convex surface. So maximum charge will remain in the convex surface of a charged body, right? If a free positive charge is placed in an electric field, then the charge will, so you know, if we place any type of charge, that is positive charge or negative charge in an electric field, it will experience force and it will move along the line of electric field, right, or in the direction of the line of force. So the options are remain in rest, so this option is not correct. It will experience force, so this option is right, and move along a certain path. You know, if a positive charge is placed in an electric field, the charge will move along the direction of line of force. So our third option will also correct. So here correct answer is option 2 and option 3. Okay. In next question they said that in case of a spherical conductor, you know, in case of a spherical conductor, if a charge is placed on the spherical conductor, then charge will be distributed uniformly all over the surface, right? So in that case intensity inside the sphere is 0. Since there is no line of force, so intensity inside the sphere will be 0. So first option is correct. And second question said that potential inside is 0. So potential inside a spherical conductor, you know, the potential inside the sphere is equal to that on the surface. That is, potential inside at any point of the sphere will be equal to the potential on the surface. So it will not be 0. And third option say that potential all over the surface will be same. So this option is correct. So here correct answer is option 1 and option 3. Okay. Here is the next MCQ question, and the question is related with the graph. They said that which one is the correct graph of electric intensity versus distance. In the foregraph they show the relation between electric intensity and distance. You know, the relation between electric intensity with the distance is described here. E is equal to 1 by 4 pi epsilon naught into q by d square. This is the relation between electric intensity and distance. So from the expression we can write that E is proportional to 1 by d square, and from the expression we can say that electric intensity will decrease if the distance is increased, and electricity intensity will increase if the distance is decreased. That is, electric intensity is inversely proportional to the square of the distance between the two charges. So dear student, in the first graph they said that distance versus electric intensity. So from this graph we can see that if the distance increase, then the electric intensity also increase. So this is not correct relation. And the second graph they also said that if the distance increase, then electric intensity also increase. This is not acceptable. In the third graph they said that the electric intensity remain constant with the distance, but from the expression we can say that electric intensity depends on distance. So this option is not correct. And finally they said that when the distance increase, the graph going to downward, that is, the value of the intensity decreases. So this is the correct option for the relation of electric intensity and distance, right? And in the next question they said that on which factor the flow of charge depends. So from the basic of electric current we can say that the flow of charge will depends on potential difference between two points. That is, electric current or the flow of charge depends on the potential difference between two points. So correct answer will be potential difference. Right. In the next question they said that the potential of a point is 30 volt the potential of a point is 30 volt. What amount of work need to be done to bring 2 coulomb charge to the point from the infinity? So dear student, from the mathematical definition of potential, you know that the amount of work in bringing 1 coulomb positive charge from infinity to a point of an electric field is known as potential of that point. And from the expression we can say that potential V is equal to W by Q, right? So we can write that W is equal to V into Q. Here the value of V is 30 volt multiplied by value of Q is 2 coulomb. So answer will be 60 joule. This is the required amount of work to bring 2 coulomb positive charge from infinity to a point of an electric field, right? I hope you got it, right? Dear student, here is our next question, and question number 10. They said the distance between 2 points in a uniform electric field having intensity of 5 Newton per coulomb. This is the intensity of the electric field is 10 centimeter. This is the distance between the 2 points. What is the potential difference between the 2 points? So dear student, here 2 quantities are given, electric intensity and distance, but we need to determine the potential difference between the 2 points. You know, the relation between potential difference, electric intensity and distance can be expressed as potential difference V is equal to E multiplied by D. This is the relation between potential difference, electric intensity and distance. Here the electric intensity is 5 Newton per coulomb and distance is 10 centimeter. That is, it will be 0.1 meter, right? And after the calculation you will get 0.5 and unit will be volt. This is the answer of this question. Here the next question said that what is the potential difference between 2 points in an equipotential surface? You know, equipotential surface means the surface where the potential of the all points are same. That type of surface are known as equipotential surface. So from the definition we can say that potential of all surface are same, so there is no difference in potential. So the potential difference between 2 points of an equipotential surface will be 0, right? 0 volt. Next question, they said that charge of how many electrons will be equal to 1 coulomb. That is, you know, the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. So how many electrons need to gather so that their total amount of charge will be 1 coulomb? So to solve this question, dear student, we can use the expression, you know, amount of charge is equal to N multiplied by E. Here Q is total charge, N is number of electron and E is the charge of electron. So from the expression we can determine the value of N, that is the number of electron, will be Q divided by E. So here value of Q is 1 coulomb and E charge of electron 1.6 into 10 to the power minus 19 coulomb. So after the calculation you will get 6.25 into 10 to the power 18 electrons, right? In our next question, this is a situation based question. We have to answer the next 2 questions on the basis of this STEM, right? Here in the figure they show 2 spheres or charged sphere. In the first sphere the radius is 3 centimeter and the amount of charge is 2 into 10 to the power minus 19 coulomb. Here is a point P inside the small sphere. The distance between the 2 centers of the 2 spheres is 4 meter. In the large sphere the radius is 4 centimeter, that is Here the radius is 3 centimeter and here the radius is 4 centimeter. So obviously this is a large sphere, but the amount of charge in both sphere are same, 2 into 10 to the power minus 9, 2 into 10 to the power minus 9. Inside the second sphere there is also a point which is denoted by Q. So according to first question, 13 question number 13, they said that according to the steam. So on the figure, observing this figure, we can observe this option: potential at P is more than that at Q. So dear student, potential of a sphere is we know is equal to 1 by 4 pi epsilon naught Q by R. So from these two expression, dear student, you know amount of charge is same. So amount of value, the value of Q will be same in both cases, but the radius of the smaller sphere is 3 centimeter and that of the larger sphere is 4 centimeter. So since the value for the first sphere is smaller, so in that case the potential for the first sphere will be more. So potential at P is more than that of Q. So first option is correct. And the second option, they said that intensity at point P and Q are 0. You know the intensity at a point inside an sphere will be 0. So here P and Q both are inside of the two spheres. So intensity in both points will be 0. This option also is correct. In the last option, they said that capacitance of the large sphere is more than that of the smaller sphere. You know capacitance of a sphere C is equal to 4 pi epsilon naught R. So from the expression we can say that capacitance is directly proportional to radius R. So in the expression we can see that radius of the larger smaller is more. So we can say that the capacitance will of the larger sphere will be more. So third option also is correct. Here three options are correct for the question number 13. Okay. In next question, they said that at which point on the line connecting the center of the two spheres will be 0. Okay. Dear student, if we consider, so intensity in this point denoted by x, a point suppose A is 0, that is the intensity for the first charge and second charge will be same. So the resultant intensity will be 0 at the point A. So distance from the first charge or sphere if denoted by x, so in that case distance from the second sphere will be 4 minus x, right? So from the expression or steam we can say that if intensity for the first charge is denoted by E1, then E1 will be 1 by 4 pi epsilon naught Q1 by x square. Similarly, intensity for the second charge E2 is equal to 1 by 4 pi epsilon naught Q2 by 4 minus x whole square. So dear student, according to the question, the intensity will be 0, that is the value of E1, E2 will be equal and opposite. So from the expression we can write that Q1 by x square is equal to Q2 by 4 minus x whole square. Here the value of Q1 and Q2 are same, so omitting from the both side we can write the x square is equal to 4 minus x whole square. So after solving this equation you will get x is equal to 2, that is the distance of the neutral point, that is the point at which the intensity will be 0 will be 2 meter from the first charge, right? So this is the required answer for the question number 14. Okay, right. Here are some of our next questions. In question 15 they said that what is the potential difference of earth? You know the potential difference or potential of earth is 0. In question 16 they said that what is mean by 1 volt? You know 1 volt mean 1 joule per coulomb. 1 volt mean 1 joule per coulomb. 1 volt is equal to 1 joule per coulomb. Okay. What is the unit of electric intensity? The unit of electric intensity will be Newton per coulomb. What is the value of dielectric constant of vacuum? You know, the dielectric constant of vacuum is 1. That is the value of K for vacuum or air medium is 1. What is the possible amount of charge in a body? You know, the total amount of charge in a body can be expressed as Q is equal to NE, that is an integral multiple of the charge of electron. Here E is the charge of electron. Okay, this is the total amount of charge in a body. And last question, they said that what is the unit of product of charge and potential? So the product of charge and potential, charge, the unit of charge is coulomb and potential is volt. So the unit will be joule, right? You know, from the expression of potential difference, V is equal to W by Q. So therefore W is equal to K, V into Q. Here V means potential, so the unit of potential will be coulomb and volt, and unit of charge will be coulomb. So the product of potential and charge will be the unit of W, that is unit of work. So unit of work will be joule. So dear student, this is all about of our today's MCQ question. I hope you enjoyed it, and this class will help you a lot. So dear student, you need to practice this type of question from your textbook and from the Permittivity or the MCQ collection that we have provided to your group. So dear student, thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.